Hi, welcome to Algebra 2 Common Core. We're going to begin our transformation lesson doing shifting functions in lesson number 1. Another word for shifting functions would be doing translations. So you might want to write that in your notes as well. So a translation is going to be a movement of the function in either the vertical or horizontal direction. Let's fill in the box with all of the rules that we probably are familiar with from past lessons. If we're given the graph of the function f of x and we want to make the function f of x plus k, that's going to translate or shift the function up k units. If we are finding the function f of x minus k, that's going to translate the function down k units. So both of those are going to be vertical shifts. Looking at the function f of x minus h, because the h is inside the parentheses with the x, remember to take the opposite sign, and that means that we are going to shift our function to the right h units. F of x plus h, again looking at the opposite sign of the number that's inside the parentheses with the x, we're going to shift left h units. So throughout this lesson we're going to apply all of these different transformations, the translations. Exercise number 1, we are given the graph of f of x equals x squared. So take a few minutes and let's graph the function f of x equals x squared on each of your axes. That's our parabola that has its vertex at the origin. It's our normal parent function of the parabola. Then come back and we'll do all the shifts for this function. So for the first one, I see that I want to find f of x plus 3. Of course, that means that we are going to shift our graph up 3 units. So on my graph, I am going to go 3 units from the vertex, and I am going to make my parabola with a vertex at the point 0, 3. F of x minus 2, that's going to mean that we are going to go down 2 units. So I'm going to take my parabola, and I'm going to shift every point down 2 units so that its vertex is going to be at the point 0, negative 2. The shape should stay the same. For part C, f of x minus 1 means that we are going to shift our parabola to the right 1 unit. So that's a horizontal shift, so I'm going to count to the right 1 unit, and I'm going to make my parabola look like this. F of x plus 2 means that we are going to shift to the left 2 units. So on my graph, the vertex will go over to the point negative 2, 0, and will look something like this. So you should be familiar with the translations of the x squared function. In exercise number 2, we're going to start with a different function. F of x equals the absolute value of x. This is another parent function that you should be familiar with. Let's make a table of values for the function f of x equals the absolute value of x. So I've got my x column and my f of x column. And all we're doing is taking the absolute value of the x coordinate. So if, for example, I'm starting with negative 2, the absolute value of negative 2 is positive 2. Absolute value of negative 1 is positive 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So graphing the parent function, I'm going to have the point of this down at the vertex, or the point is going to be at 0, 0 at the origin, and I'm going to connect all of the points along the diagonal line through quadrant number 2. So that will look like this, and along the diagonal line through quadrant number 1, looking like this. So this is my function f of x. We should be familiar with that V-shaped function, absolute value of x. Now let's go over to part B where we want to do a translation. But you'll notice that we have a double translation in this example. The f of x plus 2 should denote that we are moving our graph to the left 2 units. But then the subtract 3 at the end means that we're going to take that output and we're going to go down 3 units. So I can go ahead and take every point on my graph and go to the left 2 and down 3. So counting from the point, left 2, down 3 puts my new point over here at -2, -3. I'm going to take every point and go to the left 2, down 3, to the left 2, down 3, and I'm going to get this new graph that looks like a V that has been shifted. Going from this point over here at 1, 1 to the left 2 and down 3 puts me right here. Going from this point over here at 2, 2, left 2 and down 3 puts me at this point. And I can go ahead and make the rest of the diagonal points, making this V. So the blue graph is the graph of g of x, the translated graph. So obviously the difference between f of x and g of x is what we've written down already. We're going to go left 2 units and down 3 units. Now let's look at some of the important properties of our graph. First of all, for the f of x graph, I know that it's got a minimum point at the point 0, 0. But g of x has its minimum. If I take that point 0, 0 and go to the left 2 and down 3, its minimum is going to be at the point -2, -3. These will help me to identify the domain and range for this graph. So the domain for my original parent function is all real numbers, going from -infinity to +infinity. The domain for g of x is exactly the same. Because all real numbers were involved to begin with, I'm still going to be able to use all real numbers for the domain. What changes is, of course, the range. For f of x, the range is everything from 0 to infinity, but for g of x, the range is going to be everything from -3 to infinity. So I'm looking at the y coordinates now. In example number 3, let's go back to our parent function f of x equals x squared. I'm going to make a table of values for that one so that we can get some exact coordinates for the new graph as well. So for example, when x is -2, -2 squared is 4. When x is -1, -1 squared is 1. When x is 0, my y value is 0. When x is 1, I square that and get a 1. When x is 2, I square that and get 4. So take a minute to plot the parent function f of x, giving us the parabola that goes through the origin. And I'm going to label that f of x. In part B, we want to take the new function g of x. That's going to be the translation f of x minus 1 plus 2. Think about that for a minute and see if you can figure out what that translation is. G of x should be the translation of f of x by moving to the right 1 unit and then up 2 units. So I can do that to my table of values as well. I'm going to take every x coordinate and I'm going to move to the right 1. So I'm going to add 1 to the x coordinate. So -2 becomes a -1, -1 becomes a 0, 0 becomes 1, 1 becomes 2, 2 becomes 3. Each y coordinate is going to go up 2, so I'm going to add 2 to each y coordinate. So 4 becomes 6, 1 will become 3, 0 becomes 2, 1 becomes 3, and 4 becomes 6. So now take a minute and plot those points. -1, 6, 0, 3, 1, 2, 2, 3, and 3, 6. Connect those points to make our parabola and label the blue one g of x. So the differences between the f of x graph and the g of x graph: our f of x graph has its minimum or vertex at the point 0, 0. It has its domain as all real numbers, or again you can write it as -infinity to infinity. And it has its range 0 to infinity. So that's my original parabola. The g of x function has as its vertex the point 1, 2 because I've moved my old vertex to the right 1 and up 2. The domain stays as the set of real numbers, and the range is going to be all the numbers from 2 to positive infinity. In exercises 4 and 5, we're given a function, and it doesn't represent necessarily an equation. So we want to start with the function that's given to us, and we want to find different things about that function after we do some translations. So for exercise number 4, I'm given the function f of x, and I want to find a new function g of x, which is defined as f of x minus 3 plus 1. I'm actually going to go down to part B first of all and talk about what that transformation is going to be. The f of x minus 3 means that I'm going to shift my graph to the right 3 units, and then I'm going to shift my graph up 1 unit. So we can take a minute and we can graph moving each point right 3 units and up 1 unit. So for example, let's take this point over here at the beginning of my function, and let's move that point over 3 units to the right and up 1 unit. So it translates over to here. Taking this point right here to the right 3 units and up 1 unit would go to here. Let's take this point right here, and you'll notice that I'm kind of taking the points of this function, and I'm going to the right 3 units and up 1 unit, so I'm going to go right to here. And last, let's take a look at this point right here. Go to the right 3 units and up 1 unit, so it brings me to that spot right there. So I can now connect those points and get my new graph for g of x. Now let's go back to part A, and in part A it says, what's the value of g of 0? I'm going to start by calculating this algebraically. So I'm going to say to get g of 0, that means that the input is 0. So when I input into 0, let's go to our definition for g, and we're going to say f of the x input is 0, so I'm going to say 0 minus 3, and then I'm going to take that answer and I'm going to add 1. But this is just the same as the function value at -3 plus 1. So I'm going to use my graph to find for my original function the function value at -3. So when I count over, I see here's -3 on my x-axis. My function value is this output, so it's equal to 1. So f of -3 is 1, but then I'm going to add 1 on because it says take the answer and add 1, so I should get an answer of 2. So when I've calculated this using my original function, I see that the answer turns out to be 2. Now when I go back to my original graph, g of 0 would just mean let's look at the blue graph now. So when I look at the blue graph to check my answer, and I find an input of 0, here's my x-coordinate of 0 on my g graph, and I see that yes, indeed, the answer is right here. The y-coordinate is 2. So on the g graph, when the input is 0, the output is equal to 2. So that corresponds to the algebraic answer that I found just a minute ago. In exercise number 5, let's look at this new definition and new original function f of x. So for my new function g of x, it says f of x minus 2. So that, of course, means let's take our f of x function and let's go to the right 2 units. And then plus 3 means let's take our graph and shift it up 3 units. So go point by point on your original function. So here we go. Here's a point on my original function. I'm going to go over 2 to the right, up 3, and I'm going to get a point right here. Let's take the point that's located at the tip of the graph right here. Let's go over 2 to the right and up 3, and that's going to bring me to that point right there. Let's take the last point on the graph right here. Let's go to the right 2 and up 3, and that's going to bring me to that point right there. So connect all of these points on your graph. Ooh, that was kind of messy. Let me try that one again. So this new blue graph is now going to be the graph of g of x. So that helps me answer the questions. In part A, what is the domain of g of x? I see that my graph begins at an x value of negative 3 and finishes at an x value of 4. So my domain, I should make sure that I am using a closed bracket on that one, not a curved bracket. So let's go from negative 3 to 4 with a square bracket, and that defines my domain for g of x. For the range, again, I'm looking at the blue graph, so I'm going to go from a range, a y value also of negative 3. That's just because on my y-axis, my lowest point is at negative 3, but my highest point is located at 6, so therefore my range goes from negative 3 to 6. So translations are going to be really important for us when we're talking about all kinds of parent functions. And as you could see today, translations are one of our easiest kinds of transformations. In class, we're going to be working with some more translations as well as other transformations. So we'll be using different colored pens when we draw our different graphs. Thanks for working with me today, and we'll see you next time.